Good afternoon, everybody. Thank you for being here. I'd like to start off by thanking our generous hosts and the sponsors that have made today possible. So thank you very much for them. And I'm just going to spend a little bit of time with you sharing my perspectives on API security, where we are, and how we can work together collectively to improve this critical area. So I think this discussion is very important, particularly today. At this particular point in time, because across a multitude of industries, we are about to hit, or in many cases have already hit, a critical inflection point in our ability to support very large, complex, monolithic system environments in which they were originally designed. After decades of building and integrating one fit-for-purpose application after another fit-for-purpose application, and yet another fit-for-purpose application, we really haven't been able to find that balance that we really need of security, the granular delivery of our security model in an end-to-end framework around our APIs. So after decades of building these, we need additional ways to provide security services above and beyond the standard identity and access management and infrastructure models that we depend on today. So when we take the weight of all these large complex systems and we boil them down into more manageable pieces that work in support of one another, we can take advantage of APIs in new and interesting ways. At the core of this is trust. So what we want to do is we want to enable that trust and earn that trust and maintain that trust each and every day. And we can increase that trust when we empower and enable the user to own their identity. After all, at the beginning of each and every transaction, isn't it the identity of the entity for which we are conducting a transaction that is the most critical element? But today, identity is a much broader discussion. After all, what is my identity today on the internet? And who have I enabled to use my identity to serve me? Is it a passport? Is it a driver's license? Is it my account number, my email address? This is where relatively recent advances in API security can help. We've talked about building security in from the beginning for decades. But in this new world of APIs, we are now seeing API protocols and service models mature to the point where we can have a true end-to-end security solution and build it in from the beginning. We can have distributed authentication and authorization services within the cloud that enables more granular security services, thereby making business processes more tailored and increasing value to clients that is more customizable. Instead of a one-size-fits-all approach, we now have a trust model that can enable unique services that are not dependent on monolithic identification and access control mechanisms. I can distribute them, embed them for security within the operating environment by creating wrappers that provide context for each service, thereby distributing the trust model, which in itself increases trust and enables innovation. Think about the blockchain for a moment. Why is it appealing for so many? At its core, it's simply decentralizing versus a centralized trust model. In other words, the trust is fundamentally built on everything having access to a public ledger vice a few with a private ledger. There's no central provider, therefore there's no one place to fail. By freeing each API to focus on what it does best and to keep them as simple as possible makes them nimble. In turn, though, they need a means by which to establish context in order to establish that trust and enable the appropriate security controls. Instead of locking down each system based on their unique functions, the API is freed up to do what they need to do, and the context from a security perspective is provided by that wrapper. Because that is independent of the specific application, that security context enables that application just to focus on what the API needs to do. That is to say, the service that API provides was created with every other component of the application built for that specific purpose. Many current applications are not interoperable from a security perspective because each of them was built independently from every other system, and there is no common context by which to securely exchange information. As much as we'd like to deny it, put it off, or openly embrace it, for the most part, the current set of cloud solutions still have some fundamental challenges from a security perspective that cannot be met with traditional tools, processes, or technologies. For example, microservices are now being delivered with new granular levels of assurance to address many of the fundamental challenges with how to operate securely independent of those monolithic security architectures that we're forced to live in within today. All too often, we spend a lot more time and energy to integrate expensive workarounds that sacrifice security best practices in the name of getting it up and running. So then we have to bolt on new tools down the road, which just add more complexity and create even more issues over the long run. In turn, this presents significant vulnerability management challenges and an ever-growing number of attack vectors. At the same time, our adversaries have identified large numbers of lucrative targets with high returns on investment that present them with very little to no downside risk. The barriers to entry are now so low, and the surface area has become so large that the broad-scale attacks that create a lot of noise out there are now being replaced by far more targeted attacks that, on the aggregate, are barely noticed but provide a larger return with more sophistication and less effort by our adversaries. So what about maturity in these key technology areas? What are some of the things that we can do? What are the things we can lean on to improve? So when it comes to the cloud, where we've seen exceptional value over the past decade, it's not been until recently that we've really seen the security models mature in these key technology areas. These API security protocols are more flexible and scalable. Identity and access management solutions via tokenization enable us to do greater granularity of security. Infrastructure models that tie it all together without being locked into one or a small handful of solution providers. And new DevOps models that greatly accelerate timelines in delivering a series of independent microservices that scale more effectively and expediently. Along these lines, several foundational technologies have matured over the past 3 to 5 years that will build upon existing tools and standards that are integrating the security stack to give us a true end-to-end solution. So where and how do we adopt these technology processes to embrace and manage these new APIs within this risk paradigm? The key is technology and the businesses need to partner together to adopt a long-term API vision. This can be done through a capability model that focuses in one way the industry is effective and efficient in becoming more integrated and to manage the risk more effectively. A greater duality across the business plane and technology is what's critical. What are the implications on the business and technology from a broad API strategy? How are you engaging in that discussion? We don't look at it from a single application perspective. What we mean by broadly is mapping new APIs to new capabilities across the business processes, which can introduce additional risks with respect to where and how these APIs are adopted to enable these new processes. So what you must do is you have to start thinking about where do you govern it, and where do you manage it, and what are the risk implications? So at the end of the day, we need to reduce the attack surface area and the attack vectors. As we go to containers holding an API, we are less concerned with the operating system and more on how the API was written. Abstraction can also be done by running it in an Amazon or Azure environment or anywhere, even if there is a different infrastructure. We can still manage it. That's the key. Can we still manage it? Can we isolate core components, give us the ability to perform access management and risk management, and utilize tools to isolate the most critical risks with enhanced controls in the data and control plane? We're going to move from simply providing security at the network layer and the boundary and the device to providing it actually within the data and the application stack. By doing this, you can diversify your providers, and you can diversify the geography footprint that you provide those services. Flexibility around deployment and access requires that those APIs be integrated across different planes. We also want federation, so that APIs can be accessible at different locations. The value to the business is flexibility, but it needs to be managed. We cannot build every API over and over as the security context for that application changes. So we want wrappers around that API with automation that always gives those features in an automated way. This will reduce the attack surface area, and it will give an aggregation of that risk to a smaller and more manageable footprint. More options introduces more opportunities for errors and security flaws. The more options you have, the more opportunities to make those mistakes. So when it's more strictly defined, security can be provided in a very specific way. This flexibility creates more opportunities for good and bad. So how do you manage the bad side of it? Well, your ability to run an API from multiple locations and using multiple authentication providers mitigates some of that risk. What do I mean by that? Well, you can establish the location of a user. I can identify the specific tech stack that I want that user to use. I can use multiple authentication providers to disperse that risk. And that flexibility, while it introduces potential security flaws, it also means that we need to do it in a more managed and sophisticated way. So how will we do that? Well, the key is the capability model. The capability model is business-driven, not technology-driven. So when you have discussions with your business colleagues, don't focus on the technology, focus on what you need the APIs to be doing. So as you build a capability, such as a trade or a payment service, you can interlink multiple business processes more effectively on doing it on a microservices layer. So perhaps a trade of a security is a component of a broader business capability that may need to be executed very differently for a wealth manager versus an institutional manager or someone working in a retail space. Therefore, we build APIs around these capability models to drive new business very quickly. Think of the API as a set of Legos. Traditionally, we develop those around legacy technology topologies. Therefore, we are bound. We're almost handcuffed by that traditional architecture. As a result, they are not very granular, and they have no additional context outside the specific fit-for-purpose design. What we want to do is create that context for the APIs independent of how the API functions. Now we want to build APIs that are contextually aware of the business, so they're not dependent on those processes that are defined by those monolithic systems of the past. They are free to serve multiple purposes across a multitude of businesses and deliver those service models in a more effective way. The reality is the concept of an application is disappearing. If you have an HR system, if you have a payment system, if you have a trading system, on and on and on, we're not going to be focused on those systems. We're not going to be focused on the development of those applications. Now we want to build hundreds, if not thousands, of APIs that can be used across multiple environments within the ecosystem. And then we add that context through the wrapper. We need to change the ownership of our security model. We need to bring in the application developer. We need to bring in the database owners. We can't just rely on the infrastructure. What we want to do now is build APIs for logs, for example. So if I'm a security professional, instead of going to my application developers and saying, send me my logs, what I should be doing is developing security APIs that are forced to be used by the infrastructure, and then those APIs automatically come to me. The application developer doesn't need to worry about what are the rules set that I need to develop my logging. They simply subscribe to that security service as an API, and that gives it the context that it needs. And then those logs can be delivered in multiple ways. You may have a service provider that needs to provide a much greater granularity of that log information, so you simply point them to the appropriate wrapper, and then you change it once in one central library rather than having to manage all these individual applications. Eventually, these individual functions will be delivered independent of the context of the business, so that context needs to provide whatever authentication, access control, monitoring, or compliance check is needed. To write an API to understand what you want that risk engine to evaluate through the wrapper and its libraries is also critical. So you are constantly using them over and over as declarative controls to what the API can or cannot do, thereby feeding that context to the API based on its business function. So when we look at the API lifecycle and process, we have lots of places that come into play. The first step is to focus on the requirement, how they will be tracked and how they will be managed, and how the source and images will be tested so that they are orchestrated appropriately with the right image repositories. Well, then you have to deploy them. This second step requires a mature capability model that lays out your understanding of the requirement so you can do the mapping at an early stage. Remember, we're talking about building security in from the beginning. APIs enable you to be able to do that in much more effective ways. This enables you to scale and abstract at development stages later in the process because the capability model is what determines and maintains those controls at the appropriate place and time. The capability model, by being used in the early stages and being negotiated with the business up front, enables you to build new processes over and over and over without redeploying a brand new application. The challenge with so many APIs is that you can't code now and then hope to get them right later. Right? So right now when we develop applications, we kind of get it to that 80% solution and then we field it. What you really need to do is be able to have those libraries, have that context established up front so that when you build it, you have that common structure. So it's difficult to manage the wrappers, and a capability model is what gives you the way to tackle that problem. If a new requirement is needed later on, we can look at the capability model as the authoritative source to make sure we deliver new APIs with the new wrapper rather than rebuilding everything. Each time you make an update, you don't need to recompile everything. You just simply need to deliver a new update of the wrapper through your library. So in that case, we need to know which ones are specific to HR, which ones are specific to finance, what is specific to other parts of the businesses, so that we can map the technology effectively to how the business looks at their particular functions, which gives you a way to tackle new requirements in a controlled and logical way. When I want to deploy an API, for example, I write that wrapper to give it context. So for example, I need 3 virtual machines, I need maybe 10 different types of OSs. I can define how that API connects to the internet. You can provide other controls to define how the API integrates with the database, how it integrates with the network, how it works with your various load balancers, and the wrapper's context for everything the API needs to function in that business process. You can do the same across a number of other platforms. It doesn't matter whether it's Azure, Amazon Web Services, or whatever it is that you have to deliver it to. So in conclusion, building top-down around the API security across the entire lifecycle is ultimately the goal. And this is what the API environment today gives you. One of the examples that we have at BNY Mellon is our example of Nexen. Nexen is a pilot that incorporates multiple solutions in our business and enables our clients and our third parties to integrate with us in new and exciting ways via those secured APIs. By mapping APIs to our capability model, we've reduced complexity and the fragmented way that we've delivered those services, and we're able to provide granular services in a much more concentrated way. So once again, thank you for your time this afternoon. I look forward to any questions that you may have offline, and thank you for your time.